Imagine you're standing by the side of the road when a fast sports car drives by you, making a sound kind of like that. So the sound is higher as it's coming towards you, and it's lower as it's moving away from you. So there's some interesting interaction between sound and motion, which we call the Doppler effect.
The first thing we need to understand is sound. Now, sound is actually just a bunch of pulses being sent through the air, and you can feel that really easily. Just go like this.
So to make that funny noise, Josh is sending air through his lips, which are then bouncing off each other at some rate. If you look closely, you can see it, but you can also hear the sound that he's making.
Now, if you squeeze your lips together tighter, then they bounce against each other faster, like this.
And as they're bouncing faster, a faster rate of vibration means that the pitch that you hear is higher. So how does motion come into this? Well, imagine that your friend is standing over here throwing snowballs at you one by one. Now, which would you rather have? Your friend just standing there throwing snowballs at you, or running towards you throwing snowballs at you at the same rate? So even if he's throwing the snowballs at the same rate, you receive more of them if he's coming towards you.
And if your friend's running away from you throwing the balls, you're even happier because you'll get hit less and less often.
So this same phenomenon happens with sound. People had discovered this theoretically, but there's no really easy way to test this, because back in the 1800s, there weren't any fast cars to just drive by you and hear this sound.
Yeah, you didn't have this. I mean, this happens to us every day, but in 1840, it never happened. Until railroads were being built. There was a new train line from Utrecht to Amsterdam. And so this guy, Buys Ballot, decided to test this idea about sound by putting a bunch of trumpet players on a train.
So what that does is that they play a certain pitch while they're riding on the train. That's guaranteed to be the same pitch the whole train ride, and you can put somebody on the ground and listen as the train goes by and hear the pitch shift.
Now, we still have trumpets,
Luckily,
like this one.
Josh plays the trumpet.
But instead of using a train, we're going to use a car.
First, we'll ride with the trumpet to see how it sounds. Now, we'll listen to the trumpet as it drives by. Finally, let's hear the constant pitch emitted by the trumpet together with the Doppler shift heard from the roadside.
So one interesting thing to notice happens from our experimental setup. So here's the road. Car was driving by here, and we were standing very close to the road right there. So what we heard is a pitch shift that happened very fast, like this. So the pitch was only changing in this area right here. Now if we were standing a little farther away from the road, we would hear the pitch change happen much more gradually, like this. It would start and end at the same pitches, but the change would happen over a much longer period of time.
The other really interesting thing about the Doppler effect is that it works for light, too.
And in fact, that was Doppler's original motivation for studying this effect.
And with light, instead of the pitch changing, the color changes. And the Doppler effect is called the red shift, often. And the red shift is the reason we know that the universe is expanding. Check that out.